To graph the rational function here, you need to find the asymptotes. First, you're going to want to factor the denominator. The GCF here is x. Once you factor the x out, you're left with x squared plus 2x plus 1. You need two things that multiply to give you 1 and the same two things that add to give you 2. This is a perfect square trinomial, which means that it factors into an x plus 1 quantity squared. To determine if it's a perfect square trinomial, you basically ask yourself 3 questions. Question 1. Is the first term x squared a perfect square? Yes, it is. And beside it, write down its square root. Second question. Is the last term, 1, a perfect square? Yes, it is. Write down its square root, 1. Third question. If I take the two answers I got from questions 1 and 2, multiply them together, and then double it, does that give me the middle term? And the sign doesn't matter. If the answer is yes, then it's a perfect square trinomial. To figure out how to factor it then, you take this answer, you put it in the first position. You take the answer to question 2 and put it in this position. You put the sign of the middle term, and that goes between those, and then you square it. It's a perfect square trinomial. The numerator doesn't factor. So some things cancel here. You can cancel an x from the top and the bottom. As soon as you cancel something, automatically, someplace you need to write whole. You can have a hole in your graph when you cancel. Whatever you crossed off, set it equal to 0 and solve it. This is already solved. A hole has an x value and it has a y value. So we're going to find that y value here in a moment. So this simplifies to y equals x over the sum of x and 1 squared, comma, but there's a hole in the graph at 0 something. This equation does not resemble a parent. If we could have got rid of the x from the top, so it was a 1 over this bottom, then it would resemble a parent, but it's not the case here. So we need to figure out where the y coordinate is for this hole and find our vertical, horizontal, or slant asymptotes. Let's figure out what the y value is for this hole. Take what's left of your equation and replace the x's with 0, and that will tell you what the y coordinate is of your hole. Well, looks like it's going to be 0 because we get 0 over 1 squared. So there's a hole at 0, 0. Asymptotes. Vertical asymptote, take your denominator, set it equal to 0 and solve it. Put that on my graph. Asymptotes should be dashed. I'll fix that here shortly. Horizontal. How does n compare to d? N is 1 here. d is 2, because if you multiply this out, you're going to have an x squared. You could also look at the original, 2 and 3. You don't do both. I'm just showing you that it doesn't matter which one you pick, it's the same result. The top is 1 less than the bottom, no matter which point you pick there. So we have a horizontal asymptote at y equals 0, since n is less than d. Let me draw that real quick. Should be dashed once again. Horizontal asymptote, y equals 0. Now I know that this curve crosses at 0, 0, because we have a hole there. That's basically all I know. I don't know what this curve looks like because it does not resemble a parent. So I need to pull my calculator up. Put this in and see how it looks. So my numerator is an x. My denominator is an x plus 1. It's got to be in parentheses for 2 reasons. 1, it's squared, and 2, it's the denominator. Graph. That is a weird looking curve. Can't see it very well. Let me change my window here. It's more of a standard viewing window. I still can't tell what's happening in this region very well. So it looks like here it's just one of those curves like this. Up here it may come up and then come back down. I'm guessing that's what's happening. I'm going to zoom in a little bit here, change my window, change my y maximum to a 1. See how it looks. Can you see that here? It's coming up and it's starting to come back down. To see this even better, let me change my y minimum to a -10 or -1. It's coming up and then back down. So here's what the curve looks like. We got this here, and this part, and then over here it's coming up, comes up, and then it starts to come back down. With the knowledge that I have, there's no way for me to know the graph is going to look like that. Personally, I have to use my calculator. That's it for number 1. Number 2, anytime you start out these problems, you need to start out by factoring. The numerator is already factored. The denominator, not so much. The GCF here is x squared, leaving us with the GCF is x cubed, leaving us with x squared minus 4. X squared minus 4 is a difference of 2 squares. Difference of 2 squares factors into an x minus 2 and an x plus 2. X minus 2's cancel. When I say cancel, it means you divide one by the other. Something divided by itself leaves you with a 1 in the numerator. As soon as you cross things off, it means there's a hole in the graph. Take whatever you crossed off, set it equal to 0, and solve it. So there's a hole at 2 something. What's left of our equation is y equals 1 over x cubed times the sum of x and 2. This does not resemble a parent in any way, shape, or form. I'm going to go ahead and distribute the x cubed. So it's 1 over x to the 4th plus 2x cubed. Plus there's a hole at 2 something. Figure out what that something is. You take what's left of this equation and replace the x's with 2's. Two to the 4th, 2 times 2 is 4, times 2 is 8, times 2 is 16. Here we got 2 cubed times another 2, which is essentially 2 to the 4th, which is also 16. We got 1/32. (16 plus 16 is 32. So we have a hole with the ordered pair 2, 1/32. So I should have written this a little bit better. Let me change this to an arrow and say y equals. So here is what you're graphing. This does not resemble a parent equation. Therefore, it doesn't resemble a parent graph. So we can't graph it by memory. We have to figure out what our asymptotes are and then ask our calculator what the graph looks like. Vertical asymptotes, take your denominator. I'm going to use the factored version, set it equal to 0. Set each factor equal to 0. Solve each of those, you get x is 0 and x is -2. Put those on my graph right away. These are supposed to be dashed, so make sure that you dash them. Horizontal asymptote, I'm just going to look at the original one. It's the simplest to look at. Comparing n to d. N is 1, d is 5. Hence, there's a horizontal asymptote at y is 0. I'm just going to label this x-axis and say horizontal asymptote y equals 0. I know there's a hole at 2, 1/32, which is about there. And that's all I know. I have no idea what this looks like. I have some theories, but I'm going to use a calculator to find out because it does not resemble a parent. One divided by, you got to use parentheses for this denominator, x to the 4th plus 2x cubed. Graph it. I didn't change my window from the previous problem. I should do that. Looks like I could see most of the graph. I'm going to change it to -5 and 5. So here's what's happening. This curve is coming down and it's going to the left. This one here resembles a parabola, and this one up here is coming down and running to the right. Your calculator is not going to do this perfectly. It just gives you ideas of what it looks like. So we have a curve like this. We have a curve like this. Then we have some kind of a weird thing happening in here, like that. No X-Intercepts, no Y-Intercepts, so that's it for that problem. Number 3, this numerator does not factor. To factor it, you need two things that multiply to get you 5 times 1. The same two things add to get you negative 10. There's no pair of numbers that do that. No pair of integers anyhow. So that doesn't factor. If it doesn't factor, compare the top and the bottom and see if things cancel. Nothing does. So then we look at this and say, does this resemble a parent graph? It doesn't. So then we find the asymptotes, then we use our calculator to figure out what the curve looks like. Find a vertical asymptote, take your denominator, set it equal to 0, and solve it. I'm going to draw that right away. Should be drawn with a dashed line. So I'm going to erase part of this here momentarily. To find horizontal asymptotes, compare n to d. N in this problem is 2, d is 1. 2 is bigger than 1, so there's no horizontal asymptote. Which means there might be a slant. Determine if there's a slant. We have to show that n is exactly d plus 1. n is 2, d is 1, 2 equals 1 plus 1. So we have a slant at y equals something. To figure out what that is, we take our numerator and divide it by our denominator. And whatever we get, however many times this goes into this evenly, that's what y is equal to. How many times does x go into 5x squared? Well, it goes into it 5x times. Then take 5x times x, we get 5x squared. Take 5x times a minus 2 and we get minus 10x. And then, instead of keeping it like this, we add and we change the signs of each of these terms. In other words, we're subtracting. But I think it's easier, instead of just saying subtract, that you add and change the signs. 5x squared plus a negative 5x squared gives us 0. Minus 10x plus 10x gives us 0. Bring down the 1. How many times will x go into 1? It won't go into it. As soon as this exponent, which is technically a 0, is less than what you're dividing by, this exponent, which is a 1, everything left is a remainder. We don't even care about the remainder. All we care about is how many times it goes into it evenly. It goes into it evenly 5x times. Therefore, our slant asymptote is y equals 5x. So then we need to graph this slant asymptote. It has a y-intercept of 0 and it has a slant of 5. So 0, 0, go to the right one and up 5. Draw a line through that for our slant asymptote. Slant asymptote should be dashed. Now what does the curve look like? Don't know, so we got to get a calculator out and see what it looks like. So input this into your calculator, hit graph, see what it looks like, and I got my window messed up. Let me change my window to, I need to change my Y maximum because I can't see where the other part of this graph is. So there's two parts to this. You have this vertical asymptote, you have this slant asymptote. Your curve is between those two in both cases. So over here you can see my graph. I really need to extend this, and I'm going to make this so that it's not to scale here on this picture. So here's my slant. Let me make that dashed. Let me label, because I didn't label this and I should have at the beginning, slant asymptote. Y equals 5x, vertical asymptote, x equals 2, and I have, according to my calculator, a curve that is here, and I have a curve that is here, like so. Looks like I have an x-intercept, I have two x-intercepts and a y-intercept here. So I hit second, calculate, value, I'm going to put 0 in, this is going to give me my y-intercept, negative 0.5. So 0, negative 0.5. And then I got two x-intercepts and my curve isn't showing that, so I need to fix that. But if I do second, calculate x-intercept, which is 0, left bound, enter, right bound, enter, and I'm not sure what just happened there. Let's try that again. Second, calculate 0, left bound, enter, right bound, enter, guess, sure, 0.1. So I had to fix this curve first of all. So my curve is coming up and back down. It's not perfectly to scale. This is not vertical. It's getting closer and closer to the asymptote. So here we have 0.10. Other x-intercept, if I ask my calculator, second, calculate 0. To the left of this, and then to the right of it. Oops, I don't want to get up there. I still need to be on this part of the curve. Have it guess. 1.9, we'll say. So I got my two parts of my curve. I have my asymptotes labeled. I have my x and y intercepts labeled. So I am finished. Number 4 should make you extremely happy. This resembles the parent. That looks like this. It's got vertical asymptote at x equals 0. It's got a horizontal asymptote at y equals 0. You don't have to show any of this work. Just trying to explain it to you. You don't have to show any work for this problem whatsoever. This right here is translated to the right one and down one. Going to the right one puts a vertical asymptote at x equals 1. Going down one gives us a horizontal asymptote y equals negative 1. Nothing else changed about the graph. Let me just make this dashed, because that's the way the asymptotes are supposed to be. And then knowing what the parent looks like, I just draw that. This picture is not to scale. It's not perfect. I'm not asking you to do it perfect. So just to make sure we're on the same page here, this right here doesn't have to be shown. At this point, there's no work. I need to know what this x-intercept is. I need to know what this y-intercept is. You can ask your calculator, or you can just do it yourself. I'm going to do it myself because I think it takes less time. So y-intercept here is negative 2. X-intercept, put 0 in for y, and get x by itself. I'm going to add 1 to both sides, multiply both sides by x minus 1, add 1 to both sides, I get an x-intercept of 2. Done. Number 5, graph the function and its inverse. This function has a parent of x cubed, which looks like this. This minus 1 moves it to the right 1, this plus 1 moves it up 1. So it's right and up, like so. Let me find the y-intercept before I finish this so I can make it somewhat accurate. Put 0 in for x. Negative 1 cubed is negative 1. Add 1 to that, you get 0. So the x and y-intercept here is 0. So this is y equals x minus 1 cubed plus 1. Must also graph its inverse. Its inverse, I'm going to replace x and y. Get y by itself. So this graph is reflected over the x-axis, the line y equals x, so it looks like this. Because of this plus 1, because of this minus 1, it goes to the right 1. And because of this plus 1, it goes up 1. So it looks a little something like this. It's not perfect, but it's pretty accurate. X and y-intercepts are labeled because they are all 0 for this problem. It resembles the parent equation, y equals x squared, which is a parabola, vertex at the origin. This times 4 stretches it vertically by 4. This minus 1 translates it down 1. So this graph looks a little something like this. Quick and easy to do. We'll call this function y. Its inverse is the same graph reflected over the line y equals x. So what would this look like if it was reflected over the line y equals x? First of all, its inverse, you interchange the x and y values of the any point. So this 0, negative 1 would be negative 1, 0 for the inverse. Hopefully you can see if this is reflected, it would look like this. That's what your graph looks like. Didn't have to do any work for that because you can hopefully see if the red graph is reflected, we'll call this y inverse, over the line y equals x, then that's going to give you the blue graph. Missing intercepts here. So I've told you at this point you can ask your calculator for these intercepts. So I'm just going to pull up this first graph. 4x squared minus 1. I'm going to ask the calculator for the x-intercepts. Actually, this graph is symmetric with the y-axis. I'm just going to ask it for one intercept. And the other one is going to be the same, but a different sign. I move to the left of my intercept, hit enter. Move to the right of my intercept, hit enter. Have it guess what the answer is. 0.5 negative. So that means this picture gets a little confusing here because so many things are happening. Negative 0.50 is this x-intercept, which means this one is 0.50. The x-intercepts for the red are the y-intercepts for the blue. So this y-intercept would be 0.5, and this y-intercept would be 0, negative 0.5. It's a mess when you're done because there's so many points labeled, but I want you to label x and y-intercepts. Number 7, this is a parabola once again. The 4 stretches it vertically by 4. This plus 1 moves it left, and the minus 2 moves it down. So we go down 1, left 1, and down 2. Stretch vertically. So it looks something like this. I want to make sure you get that y-intercept right. I might have to redraw that. To get y-intercept, I'm just going to put 0 in for my x's. My y-intercept is 2. So I want to make sure that I'm clearly showing that it's, let me just redraw this. So left 1 and down 2, y-intercept is like this. So this graph is pretty skinny. It's supposed to be a parabola, not pretty. Y-intercept is 2. The inverse of this is the same graph reflected over this line, y equals x. So instead of negative 1, negative 2, it's going to be negative 2, negative 1. And the graph is going to have an x-intercept of 2 instead of a y-intercept of 2. So maybe something like that. What's left are these y-intercepts and these x-intercepts. Let's see. I'll just do this algebraically. You could use your calculator if you wanted. To find the x-intercept of this same function here, I'm going to put 0 in for y and get x by itself. Add 2 to both sides. Divide both sides by 4. Square root both sides. Subtract 1. So the x-intercepts here, one of them is negative 1 minus the square root of 1/2. Actually, this picture is so crowded, I'm not going to write it in here. This is function y, this is function y prime. Y has x-intercepts of -1, -1/2, and -1 plus square root of 1/2. Which means that y prime has a y-intercept of -1 minus square root of 1/2 and -1 plus square root of 1/2. If your work is as disorganized as mine, you need to label the order in which things happened. Did this first, did this second, did this third, did this fourth. So the reader can see the order in which things happened. That's it for number 7. Number 8, this is the inverse of x cubed. So this graph is going to look like this. This -1 translates it to the right one, so curve looks something like this. The inverse of this graph is going to have a y-intercept of 1 instead of an x-intercept of 1. It's going to look a little something like this. Notice how these graphs are symmetric with respect to the line y equals x. Let me find the y-intercept of this. I'm going to put 0 in for x. What's -1? Which means the x-intercept for the blue curve is -1.